Yeah.
You open Replita now. Keep.
Bro, is it like, am I seen?
I'm open.
Is my audio and all working?
Audio is working. I'm
Mm-hmm.
muting myself.
Hi guys, this is Ajay S. Prakash from Section A. So I'm here to explain CircularQ. So CircularQ is basically like in a linear queue, we had, for example, we had like a size of three boxes. Sorry, a size of three, and then we are enqueuing certain elements. So for example, we say 1, 2, and 3. Um, so if we dequeue so if we dequeue the first element, that is 1 and 2, um, and the element which is left inside the queue is only 3. Um, in linear queue, will not be able to access the space which is there in the zeroth and the first index. These two spaces are wasted now. In the circular queue, we can access the space which is wasted in the linear queue. So um, here in my code, firstly, the first two lines are the header files, and then we have defined the size is equal to we have defined the size is equal to 13, um, and then the char queue size is 30. The char queue size is 13. Uh, we have initialized to char because we have, yeah, so the data type here is char because it is alphanumeric. Then we have done the for forward declaration for enq, dq, and display. Here the int rar is equal to -1 because um, um, yeah, int rar is equal to -1 because um, the rear and front both have to be -1 for the queue to be empty. Um, char element. So this is basically the element that we will be enqueuing or dequeuing. Um, in choice is basically um, the choice of so yeah, in choice is basically the choice of the user which he or she wants to access, like inside the, so this is basically under the int function we have an infinite for loop, and the user is being asked if yeah, there's a printf statement, enter 1 for enq, 2 for dq, 3 for display, and 4 for exit. um, Printf of enter your choice. So here the user can choose any one, like whichever operation he or she wants to perform. Um, the switch choice, basically this is a switch case where if the user chooses one in the options given above, the enq function is called, and we have to put a break statement. And then in the second case, the deq function is called and there's a break statement. Then the third case, the display function is called and there's a break statement. In the fourth case, the exit, the whole code, like the code will get exited. And then there's a break statement. Um, so after every um, function call, we are putting a break statement. Like if we don't do that, then the whole thing will get executed one by one. So coming to enq, so here there's a printf statement saying enter the elements that is to be enqueued, and then we are asking the user input. So the first if condition where front is equal to -1. Um, so here the condition front so here the front the front is checked if it is -1. If it is yes, then the front is declared. If it is yes, then the front is um, initialized to 0, and then the first element of the queue will get incremented, and then it is and then the element is stored inside the queue. So in the else if block, so what's happening here is the condition is checking for whether the queue is full. So here we take a condition of, let's say in our case the size of the queue is 13 elements. um, yeah, so let's say that the size of the queue is 13 elements, and over here so we have uh, a case where we have enqueued all the elements till the last index, which is the 12th index in our case. um, so and then we want to dequeue the first two elements, which is the 0th index and the first index. So we dequeue the 0th index, the element in the 0th index and the first index. um, then again we go back and yeah, then again we go back and enqueue the elements in the 0th index and the first index. So so now our rare is at 12 at the 12th index, and our sorry the rare is at first index, and our front is at the second index, as we have dequeued the first two elements. uh, so yeah, if you're checking for the else if, so the condition in the else if, it says that rare plus 1 mod size equal to front. So our rare is 1 here, and if you add 1 according to the formula, and mod size, which is 13 in our case, is equal to front, which is 2. So 2 mod 13 is equal to 2, which is true in our case. Um, Hence, the condition becomes true, and uh, the queue is full statement is like that statement will get printed. Else, here, what happens is the rare is getting initialized to rare plus 1 mod size. So here what is happening is like when we are in like for example, let's take a scenario where we have incremented all the elements till the last index, and then we want to enqueue like we want to enqueue an element more, but then it's not possible because in our case the 12th index is the last, and then if we are trying to do rare plus plus, then it's not happening because it will go to the 13th index, and then the NQ will not happen as the size of our index is only 13. So what happens is the rare gets initialized back to 0, so that the NQing can happen only when the elements are dequeued from the front. So yeah, only when the elements are dequeued from the front. um, yeah, again the elements which are enqueued, they get stored, the elements which are stored, elements in are stored in the queue rare. um, So here again we're coming back to the condition where, as I said, rare plus 1 mod size. If we consider the 12th, if we consider the enqueuing happens till the last element, which is 12th index. So basically 12 rare plus 1, that is the 12th index plus 1 mod size. Size is nothing but 13. So 13 mod 13 is nothing but 0. So here it clearly says that uh, so here it clearly says that the rare gets initialized back to 0. So coming to dq function, the front is equal to rare, and the front is equal to minus 1, and rare is equal to minus 1. In this case, the queue is empty, um, and dq cannot happen as the queue is empty. um, and then we check a condition where the front is equal to rare. um, so when imagine a scenario where, um, in our case only, when we are when we have enqueued the elements till the last, we have enqueued uh, till the last element, that is the 12th index, and we are dequeuing, and we have started the process of dequeuing continuously from the 0th element till the last but 1th element, where the front and rear both will point at 12. So in this case, what happens is, like, you cannot dequeue furthermore because there are no elements to dequeue, and so in that case, the front and rear both will get initialized to minus 1. um, and in the else block, okay, so in the else block, what happens is, front is getting initialized to front plus 1 mod size, which is, so basically, it happens. So like, if you're dequeuing from the first element till the last element, um, at one point, what happens is, okay, so basically you're at the last element and it is 12. So you increment that by 1, and then the size is, the size of our queue is 13. So then 12 plus 1 is 13, and then um, 13 mod 13 becomes, the remainder that which it gives you is 0. So the front is initialized back to 0, and in the coming back, and coming to the display condition, int I is equal to front here. um, this happens, so yeah, I have taken int is equal to I, this is for the while loop here, and we are checking a condition, if front is equal to minus 1 and rear equal to minus 1, the queue is empty. Else, printf, the queue is, and then we are displaying our queue. So here we have taken while 1 not equal to rare. In our case, 1 is front. um, uh, printf, and then we have printed the elements inside the queue. So in this case, what happens is, basically, um, in this case, so we have, in our case, we have enqueued HELLO, 1 RVU, 2 2 CS, and then when we try to then when we try to NQE, it says the queue is full. um, and then we dequeue the elements from the front, say HELLOR dequeued, and then rare is initialized, then rare is initialized back to the 0th element, and then we start enqueuing the remaining of our RVU ID, which is E015. So yeah, so then the rare element will be at the third position, and then the front element will be at the first position. Yeah, so what happens is, here, the as yeah, this condition says, that if I is not equal to rare, that is when front is not equal to rare, if that condition is true, then the elements inside the queue starts getting printed. Um, so in the first scenario, front is 5, and rear is 3, which is not equal to one another, which is not equal to one another. So 1 gets printed, and then it gets incremented, to the further indexes, and then it gets printed till S, that is the 12th element, that is the 12th index, and then again it goes back to 0, and E01 is printed. um, so till here, the statement is executed, but then for the third element it won't get executed, as the condition says that the front element should not be equal to rear. So then we just later print the rear element. So the rear element, which is third element in the which is in the third index of the array, it will be 3. Sorry, in our case it will be 5. My user number is 015, so yeah, the last 5 will get printed there. So here I'll be running my code right now. Enter the choice, so I'll be enqueuing. One, R, V, U. So yeah, here as you can see, when I tried enqueuing E, it said it cannot be enqueued as the queue is full. So we start dequeuing 5 elements from the front. So and then we start enqueuing again. We have to start enqueuing from 3, so from E. Now HELLO is being dequeued, so now we are enqueuing E. 0, 1 and 5. So now I'll be displaying the elements in my queue. So as you can see that my USN number is getting printed, and I'll be pressing 4 to exit from the code. Thank you.